Let's consider x cubed minus 2x squared plus 0.5 equals 0, an equation we've met before. We have a table of values here for y equals x cubed minus 2x squared plus 0.5. We can see a change in sign just here, and that implies there's a root in the interval -1 to 0. There's another change in sign just here, which implies a root between 0 and 1, and another change in sign just here, implying that there's a third root between 1 and 2. So we've seen for this equation that we have roots between -1 and 0, 0 and 1, and 1 and 2. Let's start with this equation and see some different arrangements. We have x cubed minus 2x squared plus 0.5 is equal to 0. We can start by keeping the x cubed on one side and moving everything else to the other. We could then get x on its own by cube rooting both sides, and this would produce for us the iteration formula xn plus 1 is equal to the cube root of 2xn squared. Take away 0.5. We've seen this formula in operation, and we know it finds the root between 1 and 2 if we start with x0 equal to 1. Let's go back to this step here and arrange differently. So starting from this step, we could just simply divide both sides by x squared, giving x is 2x squared minus 0.5 over x squared. This would give us the iteration formula xn plus 1 is 2xn squared minus 0.5 over xn squared. We haven't investigated this iteration formula, so we don't know exactly what this will do. Starting again from this same point, we could, instead of dividing through by x squared, divide both sides by x. If we do this, we get x squared equals 2x squared minus 0.5 divided by x. And we could then square root both sides, giving x is the square root of 2x squared minus 0.5 over x. This would produce the iteration formula xn plus 1 is the square root of 2xn squared minus 0.5 over xn. Once again, we haven't seen this one in operation, so we don't know what its behavior will be. Let's go back to the original equation. What we could do here is take the 0.5 across to the other side, giving us x cubed minus 2x squared is equal to minus 0.5. On the left-hand side, we could take out the common factor of x squared and open a bracket, giving us x minus 2. If we divide both sides by the bracket, we get x squared is minus 0.5 divided by x minus 2, and then square rooting both sides, we get x is the square root of minus 0.5 over x minus 2, giving us the iteration formula xn plus 1 is the square root of minus 0.5 over xn minus 2. Of course, in using this formula, we'd need to be careful to make the denominator a negative number, otherwise we'd be taking the square root of a negative number. Again, we haven't seen this one in operation, so we don't know exactly what it would do. What should be clear from this analysis is that there are lots of possible arrangements. We've hardly begun to scratch the surface here. Because of this, in the exam, they tend to give you a target. They'll give you an equation and a form to rearrange it into. As we've seen, some arrangements will give the root in this range. Others will give the root in this range. Others will give the root in this range. And yet others will probably fail to find a solution at all.